Yeah. But yeah, we have some people that haven't been coming that are staying up on by watching the Zoom sessions, which is fine, and different things like that. We've just got this changing world. So sometimes things are always changing. All right, I'm going to put this here as my item number 5, variable names, 50 characters or less. Start with the @ sign. Now, a couple of other things that they mention about these names. 2 @ signs at the beginning of a variable name signifies an SQL Server global variable. So we don't want to use that in our user-defined variables. So @ sign, let me put that in. They are system global variables. And it says that if you were to use that name, that could affect performance. So I guess the system gets confused seeing that double @ sign and thinks that it needs to do something with that variable and must go through some sort of process before it realizes that it doesn't need to. So it can cost us some overhead. Now, a couple of other things in this document that don't really necessarily qualify as rules, because the rules are kind of free and breezy. Variable names should be written in camel case. So this document, this particular document, by these people, which may or may not have anything to do with us, they want everything in camel case, so they don't want underscores. And you might go to some company where every single variable name has underscores in it. It's just going to depend on their conventions. But I agree with them. If you think about it, underscores make those variable names so much longer and stringier than camel case does. So just kind of has become a convention to stay away from those underscores. And then special characters, no special characters or spaces, of course. Put that in. Yeah, now it's a new variable, right? So use camel case and no special characters or spaces. Duh. Yeah, because that makes it a whole new variable. Now, throughout this document that I was looking at, you know, it's just one of those things that I searched for, and this is the one I found. It doesn't mean that it's an expert or anything by any means, but they do have a lot of interesting points, discussion points. Glad it's not an online class with all those discussions. So what we could discuss, though, is table names. Here's one. They say you should use singular names for your tables. Our book obviously doesn't agree, right? Because they use plural names. So like I say, that's one of those things that you could argue about forever. Prefixes. This is why we used a prefix when you guys did your group project creating those tables, so that they would be prefixed with something that indicates that that was that project. And that's a common thing to do when we're naming tables and database objects, is to prefix them like that so that they sort together. If you use a suffix at the end, that's all good and great, but then things don't sort right. So we want that prefix really is a little bit better for us. And what else do they say? Use Pascal case, camel case, whichever you want to call it again. And in their table names, they discourage the use of underscores. This is, do I?
Looking at the names where they say use camel case.
Uh-huh.
They were capitalizing each word.
Right.
Not in a lot of cases, we've been not capitalizing the first word of a field name.
of the variable name.
Yes.
And so some textbooks call it different things. I was taught that there's upper camel case where you start with an uppercase letter on your first word and lower camel case. And so what we're doing, and kind of without really talking about it, it looks like, is we're using upper camel case for our table names, lower camel case for variable names, and other types of objects like that. So I think that that's sort of like a convention, because I know when I look at some SQL code, if it's got an uppercase letter, I'm going to think that it's a table name. Our variables are staying lowercase, but that's totally just up to the people creating the database and the tables. So there are conventions and guidelines, but it's up to you as to how you do it. This document also recommends not using abbreviations, and we've used a lot of abbreviations in our table names. And again, bless you, bless you. I think that's going to determine, again, what the accepted methodology is at your company. One company that I worked for, CUST, was just a completely acceptable abbreviation for customers. That's just what they used everywhere. And so we always use that abbreviation. Another company might not. The junction tables or link tables, if you remember those from our design activity, you guys created those link tables, and we said that they resolve those many-to-many relationships so that we can have a table that establishes, you know, all of these and all of these. And when we did our database design, we kind of did this automatically. Usually we want to name those, the two table names that they're joining. Like in their example, an intersection between doctor and patient, we would want to name that the doctor-patient table. And they're using, they say Pascal case for your columns. They actually are recommending that you use the word or field ID in anything that's a primary key field. That's probably usually followed. And then foreign keys should have the exact same name as they do in the parent table. We see in our database, our test AP database, that address table is the only thing that violates this rule, right? Because we have billing address ID and shipping address ID on our customer table that both point back to that address ID table. So you'll have some variations from things, just like always, never a perfect world, but we keep trying. So I created a new page in my notes called tables, and I added a small section from what we did last time at the end. So at the end, we ran this script that declared this table, and we said that was a table variable. So just the notes that I added came from our text at the end of that little page-long section talking about what a table variable is. So in our textbook, if you're finding it, this is on page about 417, around in there. Oh, our databases have the column names starting with uppercase too, don't they? Everything starts with uppercase.
So back to the Pascal case.
Let's search for it. I'll search. Get this silly thing out of the way. I wish I could. My Skype thing's in my way. Or Zoom thing or whatever that is. Pascal case is a subset of camel case where the first letter is capitalized. And that's what they're talking about in our book. So that's their specific type. So now we're ready to look at some other types of tables. This was a table variable. Now we're going to look at temporary tables. The text shows us this awesome example, and there's a lot of information here buried in these very few paragraphs, so we're going to try to extract it out. They say that we can use temporary tables to store data in a script. These temporary tables are basically exactly the same as a table variable, except that they exist as long as your query editor window is open. So you can refer to the table from more than one script. Whoa, there, the book just disappeared on me. Don't disappear, book. I need you. There it came back. Okay, so we're going to try this. We're going to create this temporary table and use it. So let's open SQL Management Studio, and then we'll fix our notes.
We're gonna use AP or
This is on the AP one. So this is using this with keyword. So we're going to have a select statement that selects just the top one vendor ID, the average of their invoice total. No type. As average invoice. We're going to select this from our invoices table. Now we're going to group this by vendor ID and order it by our invoice average descending. Now this is this inner select statement. I want to close my curly braces here. That's going to end this with statement. Now we could run this select statement on its own. Let's select it. Can I control and select my use AP? No, so I'm going to use AP, execute that one statement first. Then I'm going to select my select statement and execute it. Make sure I don't have any sort of errors. Looks good. So it's saying vendor ID 110 is our top vendor. So they have the highest average invoice total. So our select for our as statement is working. We're going to join that with some more information. And we want to group by invoices dot vendor ID. So what's happening here besides the syntax editor being mad at me? Our with statement is going to create a temporary table. Let me back up here because this thing says so much. Figure 14.5. I wish they had their figures labeled when they say figure 14.4. Here it is. I see it. No, not that one. All right. This is on the next page. And they say, we're going to run this script too. We'll try to. This script selects the top one vendor into a temporary table. Yes, sir?
I couldn't catch up on.
That's okay. Let's look at this. And then we'll go back to that. So I want you to focus on this here right now. Stop typing. So we're saying here that looking at this script creates a local temporary table. The pound sign indicator before the variable name indicates it's a local temporary table, which we'll talk about just in a second about how that's different from the other temporary table. There's a lot of different types of tables that we can create on the fly in our scripts. So this uses a local temporary table, and the derived table is the one that we're creating where we're using the as keyword. This table is going to be derived from that select statement that's within that as clause. So that derived table is a way for us to create a temporary table that we can use across our entire SQL Management Studio session. This script, this next one, creates a local temporary table instead of using the derived table like we're going to use. So let's see if we can kind of narrow down what these differences are. I'm going to go back to our with statement that we're working on right now. Here you go, Garrett. There it is. Finish that one up. And so we'll take a look at all of them. Okay, so if we're ready, let's try and run it. Oh, all sorts of madness. It's just crazy, man. What's it start with? Just doesn't like those at all. So do I need a go statement? Doesn't seem to care about that.
It says what expecting a parenthesis.
Do you think it's my eyes? I think it's my eyes. I'm seeing curly braces everywhere instead of parentheses. Thank you, Austin. I never would have seen it. I'm seeing curly braces.
Here we go.
Parentheses, not curly braces. That helps a lot. No wonder it was so mad at me. Okay, so let's try and run it. Oh, that looks good.
That makes it run a little easier.
Yeah. So now we get out of this query the fact that our highest average invoice vendor is vendor 110, and the latest invoice we have from that vendor is 0331. So we've combined this. What we've done is first with our with clause, we created a derived table. So let's add that to our notes first. So we can have a derived table. And our derived table is created using the with syntax. I want to copy and paste my code into my notes over here. And put it over here a little ways so that I can have that example. I think I'm going to change my font a little bit on that so it stands out. There's my code. So that with syntax allows us to create a derived table. The derived table is derived from the select statement. At the beginning of the semester, we looked at the select into statement, and this with clause is very much like that. You know, we're just saying, with this as the temporary table name, use this select statement to load this table. Now, the derived table is available until our SQL Server Management Studio session ends. To say that right, not a short, sweet way to say it. So it's a little bit more, there's a longer duration than using that temporary table variable. Matter of fact, in my notes, I'm going to get rid of this word here that says temporary tables and just make my derived table at that same level. Back tab. Back tab. Fix it up because I'm thinking that's confusing to me because these are all temporary tables. So this is a derived table. Now a derived table is more efficient than a table variable. So however the system handles this, because realize the database management system is going to handle creating these temporary tables in some way that it's been programmed to do. And as these different things have developed and evolved, there's been different programming. So some of it's going to be more efficient than other pieces. Now, when we look at that SQL code that we just ran, first we created our derived table. Then we used it within this select statement. So in our select statement, we were able to use it just like it was any other table. There was nothing different. Now I should be able to add another select statement down here. Let's try just getting everything from it. Select star from top vendors. And I just want to run this code and see, does it still exist? It's giving me a syntax error. I'm not seeing it be open, be available. So we'll try some different ones as we get with some different areas because my top vendors is gone now. How about yours? It didn't stay for that long. Now I'll try to eliminate some of this fuzz here. I'm going to leave that in my notes though because that's what it says in the book, that these derived tables, a temporary table exists for the duration of the database session. If you create a temporary table in a Management Studio query editor, it exists as long as the query editor is open. So we're going to leave that in our notes, but it doesn't seem to be behaving that way. And that could be some sort of update. Now,
It's interesting, I do see DBO.J underscore top vendors
oh, really? Like it did do something?
with columns, vendor ID, and invoice too.
So it's got it there in your tables. If you look at AP.
It's under system views.
I didn't put my username in front of mine,
Oh, I didn't either.
but it did for you.
You see where mine is?
Mm-hmm. Oh, those are from last time then, huh? So, and that's our view. So we just have some different things going on using that same top vendor's name in too many ways because those were views that we created. So let's just get this in our notes and go on because we've got lots of other stuff to look at today. So I want to try to identify exactly what they're saying here. When we look at this information on page 419, notice how they're showing you the into clause. And with the into clause, we're using a pound sign for that variable name, for our table name. So that makes it a local temporary table. A local temporary table has the pound sign or number sign prefixed in front of it. And a global temporary table is prefixed with 2 pound signs. Temporary table names are limited to 116 characters. So that's a little different than what that other document I found says. That's quite a bit. Let's fix some things. They say that our temporary tables are actually stored in Temp DB. There's not any there. It's just going away. Okay. So temporary tables. The name is prefixed with the pound sign. They are stored in a system database in Temp DB. You can actually drop them. So if you are done using a temporary table, you can drop it. Otherwise, you can just wait for it to be eliminated automatically by you closing out. And I'm wondering if us using the Amazon web server is having something to do with the life cycle of our temporary tables, because we're trying to save memory on that web server and things that may not save those kinds of objects as long as it's probably a system setting. But we're going to say that it should keep them. A local temporary table only in the current session is it visible. And the name is prefixed pound sign. Now, if it's a global temporary table, these kinds are available to all sessions and they're prefixed with 2 pound signs. And these are slower to process the underived tables. So I'm going to create a global temporary table. We're going to see if you guys can access it. I'm going to move this out of the way while I do that. Okay, let's see. Got this really ugly select statement going here. I'm going to fix it. We're going to create a table, a global temporary table called hashtag random SSNs.
You don't want us to do that.
No, I'm going to do it. And it should create one table that we can all access. So we're going to see if that works. Let me figure out where my code goes. Got this this random number being cast here as big int as varchar, comma 9. And I'm going to insert. So this syntax that I'm going to run, I'm going to use our AP database, and then I'm going to create this table, random SSNs, and it's going to have some random things as default values. So anytime I issue an insert statement for that thing, it's just going to insert some random numbers. So I'm going to try running all of this, and then I'm going to select those numbers that have been loaded in there. Perfect. Now you guys try running this part and see, bless you, see if you can access that table. Can you? Did you get it?
I got 2.
You got 2 people? Yeah, it inserted 2. You guys should be able to insert default values if you want to. You get some things in there. And so there's actually companies that do this, something that runs like this first thing in the morning to create a temporary table that they use all day. That's pretty sad. What that happens is they don't have any DBA support or whatever, and it just kind of evolves. Systems can evolve that way.
Just something like you need to know, in the batch process last night, we added these policies to our insurance.
Oh, that's a really good example. Yeah, anything like that that's just constantly being updated, and that day you want those last night's available. That's a great example of how we would do it. We could also do something, or does Walmart do that? Walmart TV is always displaying things like that, you know, the top department or the top whatever. You could dynamically allocate those kinds of tables. So gives you a lot of power because you don't have to create a table permanently in the database, but you can just dynamically create something. So, yay, it worked. I don't know whose that is. Did somebody drop? Is it a gift card?
It's a Congo rewards card.
Uh-oh.
Found it on the floor.
It could be worth tons of bank. Somebody's gas money
Not for the
card.
bank,
It's not yours, Austin.
somebody buy gas this morning.
Gas card, gas card. Now I'm going to add that to our notes, that one last thing that says temporary table names are limited to 116 characters. You know, test writers, they love things like that have finite answers. Yes, you are right. No, you are wrong. I don't know that that would show up, but those are the kinds of things they love. I've got a sad face on my online textbook. I hope it keeps working. It's not working. Sad face.
Can you give us the link to that?
No, I can't. You guys can buy it though. The online one for these Muroc books, it's really cheap. I'm not sure how much they are, but you have to actually go to Muroc's website. But they sell an online version to students too. They're not one of the big publishers, so they don't do it in the same way as the other publishers like Cengage and Pearson. Theirs is just a little different. So it's a little bit harder to use.
Or can you make copies of just this section?
Just this section. It doesn't really let you copy. It only lets you print like a couple pages at a time. It's got you all locked down. So it's just like, here you go, teacher, you can use it. But I like it because I can use it. All right, so those are our different types of temporary tables. And here's a comparison of them all. There are 5 types of TSQL table objects. So we have standard table. I'm going to just see, and it won't let me zoom in very well either. Let me go this other direction.
Oh, that is the book.
There, yeah, it is the book. You should have those pages. It's just not online. So here's our 5 types. A standard table, and that's the kind of tables we like, right? Create table, drop table. A temporary table that's available while the database session is open. A table variable that's available within the script. The derived table that's available within a statement while the current statement is executing. And then there's a view, which we have created before. And again, they're available within the system until explicitly deleted. So the scope of a table is what kind of makes a lot of differences here. How long is this table alive, and how long can we access it, and who can access it? Because we saw the local table, only I could access, but that global temporary table we could all access. Now, right now, you should still be able to access it as long as my session is open. Is it going to stay available if I close?
So how did we knew it was the global table because of the double hash?
Because of the double hashtag, Yes.
I ran a select statement again for that.
No, it's got 4.
Yeah, it's got 4.
So somebody else ran some inserts. So it's dynamic. We can do that. Keep changing it.
You log off.
Okay, I'm out.
I still got it.
Is it still there?
No, mine is
Is it gone now?
Yeah.
Gone now.
Yeah,
So-
no, I don't think really cool.
To be very, very careful.
So what if we need that information for later?
Better leave that session open in some computer somewhere.
Or save the script to
Or
run
you would only work on this while I'm around.
Yeah, exactly.
If that table is created in the morning for everyone to use, if I'm the one that creates it and I leave at noon, you're screwed.
Yeah. So what you would have some sort of generic account that you would log on to, that the operations staff logs onto and executes to leave that running. It's like our operators down the road at Liggett Platt, there were certain systems where they might have 10 or 12 windows open, and they would toggle between those windows, and one window would be running some printer process and another window would be running some sort of SQL server process. So
it could even be a batch process.
right, or something that runs under a generic user account that all the operators have access to.
It runs at the end of the batch
Mhm.
process.
To create it.
And then the first job that runs in the evening closes.
Or the operators create it as soon as the batch process gets done, and then it's available. So it's definitely better to create your permanent tables, because these are designed to be temporary, dynamic, just to serve the need that you have at this particular moment. So we have to be careful with them. Now, we saw that we could use the if and else statements, and I said, how do we know how many lines of code it's going to run for the if statement and the else statement without curly braces? I've been trying to add curly braces to this SQL code all week, It won't cooperate. Right? Just like earlier, making my parentheses curly braces. So where does it know? Let's see if they tell us. We have our if Boolean expression statement, else statement. Here in this case, we have an if statement, and we're printing out some outstanding invoices overdue. Down here we have, oh, there it is, how ugly. So if we have more than one line of code that's going to be executed as the if statement body, we have to have this begin and end statement. So that's our curly braces, the begin and end clause. Notice that the end clause has a semicolon, which is unlike our curly braces.
I don't see curly braces.
It's not got them. It's using the word begin and the word end, where we would put curly braces in other programming languages. So we are using the begin and end word instead. Let's do these. Let's create a couple of if statements, select statements, so we have them. So I want a new query. We're going to use AP. And first we're going to have a script that gets the outstanding overdue invoices. We're going to use a variable or two, actually just one, and it's going to have a really long name, earliest invoice due, and it's a small date time data type. We want to select, and we're going to load our variable by setting it to the minimum invoice due date that it finds in the invoices table. And of course, we're going to add our where clause about our amount due, because we don't want to know about these old invoices if they're paid. Only the ones that aren't paid. So anything where that outstanding balance is greater than 0, we want that invoice. Now, we're only going to get that one, right? One earliest invoice. So what does this get date function do?
Just like that, doesn't it?
Do what?
For the get date method like that, doesn't it pull today's date?
Today's date, yep. Just a reminder. So if it's earlier than today, which it's going to be because they're all in 2012 or something, right? We're going to print out this message that says, yep, we have some. We're not going to tell you what they are, but we have some. Now, if we run this script, we should get this message. Outstanding invoices are overdue. Let's try it. Perfect. Now, last time, it's doing much better about putting comments in. Let's do that. So this is going to be overdue invoices. So this script is just checking to see if there are any. So it's not giving us any data about them, just saying, yep, there are, we have some. So I could copy this script, and in my notes, I want another page about if statements, and I could just put this code in here as a sample. I got some code in there for my if statements, so I just have a little example of it. So this script is kind of lacking because, you know, what's their next question going to be? Oh, well, what invoices are they? What invoices are there that are overdue? Because it's great to know that there are some, but we'd like to know which ones there are. So let's add that script. I'll do a new query and use AP again. So this one's going to be a little bit more involved. So we're going to declare a variable min invoice due as a money data type. Max invoice due as money. Earliest invoice due as a small date and time. Small date time.
You forgot.
Come. There we go. Thank you. And latest invoice due is also a small date and time. That's all of our variables. Now, after we declare our variables, we're going to do our select statement. And again, with our select statement, we're going to use the select statement to load our variables. We're going to say our minimum invoice due is equal to the minimum of our invoice total minus our payment total. Minus our credit total. I'm going to go down and put our from clause so I quit getting all those errors from invoices. Errors go away. There we go. So now it's happier with me. The only error I have is that I have a comma with nothing else, and I'm going to add more, so it'll be okay. Now I also want to load up my variable max invoice due, and I want it equal to the maximum of this. Then we're going to load up our earliest invoice due variable by setting it equal to the minimum invoice due date. And we're going to load up our latest invoice due variable by setting it equal to the maximum of our invoice due date. That's the end of our select clause. I'm going to pull my from clause up to it now. So I do want that from invoices where our invoice total minus our payment total minus our credit total is greater than 0. End of our select statement. Finally. Big one, right? Now, in our select statement, we're loading up all of those variables, and we're using a summary query so that we'll only get one result for each of those variables, right? Either the minimum of something or the maximum of something. So there's just one scalar value that we'll be putting into each of those variables based on our select statement. So now we're going to have our if statement. So if that earliest invoice due date is less than our current date, we want to do some stuff. So we're going to begin. We're going to print out a message, outstanding invoices overdue. Exclamation point. We are going to output some nice helpful information about their dates. So first, we'll use our earliest invoice due date. We're going to format those using pattern number 1. And then we're going to continue on our message with the word through, and then we'll output our ending date. Latest invoice due. We also want to format it as type 1. One last thing, they want a period. And then after we've printed out the due dates, we're going to print a little bit more information about the amounts. So amounting from $, and we're going to use our min invoice due. That's our amount field, formatted as type 1. And then we're going to say $2, Phew. So that finally concludes everything that we wanted to do if that if statement was true. So we can end our if statement body. Now we do want an else clause, and in our else clause, we are only going to have one line of code, so we don't need the begin and end clause. We're just going to print out no overdue invoices. And this is a really nice script, and a lot of people the database expertise to do scripts like this is something that they would just relegate to the programming department. So it's awesome. It can do all sorts of great things that we need. Let's see if it'll run. Now, no typos. Wow, that's awesome. So it was a crazy one. So it's saying, yep, there are outstanding invoices overdue from April. And there's a pretty big range of amounts there. That would give me a nervous breakdown. Does everybody work okay? What you got down there, Garrett? Did it not work?
Oh, the print statement for the else.
That all you need? Okay,
Yeah.
good. Looks great.
There we go.
Did you find it?
Yeah.
Now, of course, just like other programming languages, other scripting languages, we can nest our if-else statements. We just want to be careful and not get carried away so that they're not really readable. A reasonable amount of levels. Now, do you want to copy that code and put in your if statement notes? I do, because I would like to be able to find it without getting out the book.
It works.
Woohoo! So here's my if statement using the, I really think that I need a lot of notes here, but I do want to draw or something. So I'm going to use my drawing menu and maybe get a highlighter and highlight that begin and end clause, just so I remember that that was what was different about that.
So the beginning and ends are only in the
If you have more than one line of code to execute. Mhm.
Okay.
Mhm. And probably within our while loops, we'll see.
Funny, on the else statement, if you wanted to print no overdue invoices, total and new line, print total equals 0.
Uh-huh.
You would need a beginner and an end statement.
Right, if you want more than one line of code. Exactly.
almost kind of like a Python, but it's a Python with tabs.
Yeah, yeah. And I was, it does look a lot like it, doesn't it? They're all pretty similar. After you start learning things, that's when you start seeing, oh, I can pick up this language pretty easily. So whenever you guys were creating your tables, you ran into this problem, and all of you mentioned it. If you'd already created the table and you wanted to change it, oftentimes the SQL Server wouldn't let you. It's like, no, you can't make that change to a table, contains data, or whatever. So you found that pretty much we have to drop tables and recreate them, and that's real common for us as DBAs. But wouldn't it be nice if you could put an if statement in that batch file you created to say, if this table exists, drop it. Otherwise, just create it. And then we wouldn't have to worry about it. Well, we can do that. We just didn't tell you, unless you found it, which is great. But we can check to see if objects exist. And that's really important because we have to delete them if they do, right? So here's some examples. We can use the if exists clause. Notice that's pretty new, SQL Server 2016 and later. So that might be something that you wouldn't see out in the wild, wild world, but you could add. So drop object type if exists object name. So how would I interpret that? Do I say drop my table name if exists my table name? Is that what that's saying? Or am I saying drop table if exists my table name?
I think you're saying drop table or drop view or drop.
Right,
If it exists, then that name.
the name of it, exactly.
Well, actually, that's a complete database.
Huh?
That's a complete database.
Right.
Yeah, you could drop a database if it existed. So that's what they're doing, dropping the whole database, test DB, if it exists. But we could do that with a table or a view, exactly.
But that's dangerous.
So I was asking,
Uh-huh.
what would be a time when you would want to drop an entire database?
Not very often. Just to create, probably just to recreate it. Like you're in test mode and you've made a whole bunch of changes and you just want to create it again to load it with new test data, because so your script, your creation script is going to have that drop statement in there. And you guys didn't create your database because you just created entities within yours. With our Amazon web server, we're limited to 30 databases. So if you guys all created a second one, we would have gone over. So that's the only thing. Some people might have limitations like that.
The other thing is, don't do that in production.
Right, you wouldn't do that on a normal basis. Be some sort of special condition you're testing. It's a new system, a new database, usually is when you're going to see stuff like that.
Somehow your database is corrupted
Uh-huh,
and you were going to reload it from the backup.
yeah.
You want to drop.
And we're going to look next week at transaction processing and how that kind of stuff happens. But theoretically, that could be an idea. Now, let's look at the different syntax here. We have this drop object type if exists. So I want to add that to my notes. I'm going to add another page about exists. So I have drop object type if exists object name. Now, the object ID and the DB ID field are variables that are available to us. I'm going to put object ID, and they, of course, use underscores in the name, since we just saw all this stuff about not doing that. Now, an object ID, this is going to be the type of object. And then the DB underscore ID is obviously the database name. So we can have syntax like use master. Now, master is the system database. After we use master, we can say something like if DB underscore ID test DB, this is going to be our database name, is not null, meaning it exists, drop database test DB. And then, of course, we could create it again. Now, we can use that same syntax with the object ID. We can say if object underscore ID invoice copy is not null, drop table invoice copy. Now, another way to do this last one is if object ID, this is kind of icky, I like the first one better. Temp DB dot hashtag all user tables is not null, drop table hashtag all user tables. So this syntax was for a temporary table, and we're getting rid of it. And then one last syntax that we might see is if exists, select star from sys.tables where name equal invoice copy. Dot table invoice copy. Now, all of these different syntaxes are doing the same thing here across the bottom. Different table maybe, different table name, but any of these different syntaxes is completely valid. So you could see different types of syntax. This last one, we're going to those system tables. Remember we saw those different views that have been created out there for these system tables for you to see what all tables are available and all those kinds of things. We can actually select directly from those system tables to see if our table exists in the system. And if it does, then we can drop it. So we can use select statements against those system tables, those system catalog tables, however we want to. Now this syntax, I'm going to highlight.
Can you make that larger?
Sure.
The last one, if we didn't have a where clause on there, it would just drop all the tables.
Yeah, super dangerous. Really good point. Where do you need to see when it's bigger? I'll move this one down. But yes, that's exactly right. And depending on the database management system, it might come back with an error and not let you do that. Or it might just do it. It kind of just depends. We like those ones that come back with an error. Did you really mean to do this? I think you didn't. Now, what I wanted to put here with this syntax is that it's only available after with server 2016 and above. And we always have to be aware of what environment we're in. You could really easily go to work for somebody who has a different type of database management system, and a lot of these script commands might be a little different. That's pretty standard. That's usually pretty standard.
So if it's not null, is that 2016 beyond as well? Or?
No, just this one syntax up here, the highlighted one. Yeah, if exists. The if exists keyword is just 2016 and above. So that one won't be out there in any older scripts. Okay, so what about looping? We've got our if statements we know we can do. Let's look at some while statements. So our while syntax is going to be just like our if statement syntax, except our keyword will be while, and then we'll have our expression. Within our while body, if we have more than one line of code, we'll have the begin and end statements. And then if we're really poor programmers, we'll use break and continue. I need to throw those in. No, I'm just kidding, sort of. But we want to try to stay away from them. So whenever we're looking at our code, let's create this one because it looks like it's got a really good example for us. So I'll go to SQL Management Studio and open a new query. I want to use AP. Now for this one, we're going to create an invoice copy table. So I'm going to put my username prefixed in front of that like we did last time. So I'm going to have Riley, R-E, @ first, Riley, R-E, invoice copy. So everywhere we've got that term, I'm going to put my username in front of it. So if that table exists, we're going to drop it. And here's where we would really use our drop table syntax when we're in a script and, you know, making sure that we can create it new. I want to select into my invoice copy. So we're using that syntax we learned at the beginning of the semester, the select into syntax, to create that temporary table. We just have it named correctly with that pound sign now. So I want to select from the invoices, again, where we owe money. Put that in the right, nice readable syntax. Now, I've got some stuff there in my invoice copy table. We just selected into it, so there should be some rows in that table. So I'm going to use a while loop. My while loop is going to be controlled by a select statement. The select statement is going to select the sum of our due amount. So I'm going to copy that formula. From our invoice copy. Oops, I left my username off of it. Sorry about that. So I'm going to select into my temporary database and select from it. And I only want those really big invoices that are greater than or equal to 20,000. So our while statement is going to act kind of like a for each loop. For each entry or row we get returned from the select statement, we should execute our while loop body. In our while loop body, we want to do some updates to our temporary table. We want to set our credit total up by 5 cents. So every time I'm running to one of these invoices, I'm going to update how much credit we have from that vendor by a nickel. Now, we're also going to check then to a condition. We're going to select the max credit total from our invoice copy table. Isn't it something? Okay, I think we're done here. Let me end. All right. So in our if statement, we're saying, I want this to run. It's just going to kind of keep running until the max credit total that it finds in any of our rows is more than 3,000. When it hits one that's more than 3,000, it's going to break out of our loop. Otherwise, it's going to continue at the top of our loop. So is that else continue statement even necessary? Not really. It's just going to continue on with that loop at the next line anyways. Now, after our end statement, we need a semicolon because that closes out that while loop body. After that, we can select from our temporary table to see what we've got. There is a warning. This script takes a few seconds to execute, so it can take it a while before it finds everything. So let's run it. Didn't take it very long. Pretty fast, actually, huh? So pretty powerful. In our while statement.
Can I see the mom?
Sure. Is that good? That's the end. Does it go high enough?
Yeah.
Now, if I were using a programming language to execute an SQL statement and I got a result set back, I would get an entire result set back, and then I would be able to use some sort of looping structure in my programming language to process each of the rows in that result set. It would be some sort of collection. Well, sometimes when we're working with the database management system with scripting, we would like to be able to do that too. We'd like to be able to process each row. We can do that. Let's get our notes open and add a few things here. I want to add a page about my while loop. And I'm going to add that code that we toiled and labored over so hard. We're getting to be less and less English language and more SQL language in our notes, huh? That's okay, we can do that. All right, so this next section is about cursors. So I'm gonna add a page and we about cursor. So in our database results set, we usually have a collection. And if we wanna move that through that collection a row at a time, we're gonna use a cursor. And a cursor is nothing more than a pointer into our result set that shows what row we're currently processing. Let's see if we can find a picture of it, because our book does not have very many pictures. So I want to look for a database cursor. There's a Python one that looks good. How about this one? Fetch rows into a cursor. So here's my database result set. I have all these rows. And to them, in this picture, they're thinking, well, the cursor is like a programming construct that's going to process these rows. So as I move my cursor, I'm going to be looking at different rows within this result set. If I use like a for each loop in C# or in Java or in some programming language to process through those rows, I can control getting the next one, but I can't like move back 2 or forward 3. I can do that with the cursor. I can adjust my position within the cursor. So the cursor is basically the result set with a pointer to what position, what row I'm currently looking at. Now, why that's important is because I want to be able to move around within that result set and do different things. So if we look at the script that they have for us, we'll see some of the different syntaxes that we can use. First of all, we've got some system variables, @ fetch status. That's going to tell us how that worked. Did we get anything back? We also have an @ update count variable. Let's do this script and it'll make more sense then. So I want to just code it. So in this script, we're going to use AP. And I didn't do comments. So bad. This script is going to be a script that uses a cursor. I'm going to put our purposes to navigate the result set rows using a cursor. In our script, we're going to declare some variables. @ invoice ID var. It's going to be an integer. @ invoice total var. It's going to be money. @ update count, an integer. And that's our last one. Now we're going to do a set command to set our update count equal to 0. And then we're going to declare our cursor. So we have to declare our cursor just like we would declare a variable. And we're going to use that keyword cursor. Now the select statement that we want to use to fill up that result set is going to be under our for clause. I had this job once where I had to retype like thousands of mailing labels. And so I got really, really fast at typing Springfield, Missouri. That's how I feel about this invoice total minus payment total minus credit total thing. I just want to create a shortcut key for it or something. Just pop it in there. Wouldn't it? We need that. Yeah, as much as we're using it, we wish the DBA would have just put that in there. Just keep it updated programmatically. Come on. We're doing this calculation thousands of times. It'd be easier to just do it once, right? There it is. All right, so with this cursor, after we've declared it, we have to open it. Once we open it, we can read from it, but we can't use keywords like read. We fetch. Now, when we use the fetch command, we can specify next, previous, different locations within our cursor. This one, we're just going to start at the beginning and go forward. we're going to fetch the next item from our invoices cursor into our invoice ID var and our invoice total var. So our select statement that we use to establish our cursor has the invoice ID and invoice total fields. Those are the only columns that we're selecting into that cursor. And then as we fetch something from it, we're only expecting to have those two columns. And so that's how we can just fetch it right into those two that we just selected from. Now, once we've fetched that data, we can process our cursor using a while loop. We're going to use the @ fetch status system variable. And that fetch status is going to be set to -1 when we reach the end of our cursor. So while it's not equal to -1, we want to process those cursor rows. Now, within our loop, we're going to check to see if the invoice total for this invoice was greater than 1,000. If so, we're going to update the invoices and set our credit total equal to our credit total plus our invoice total times 0.1. Now, the update needs to be qualified with a where clause. We don't want to update every row. We only want to update the row where the invoice ID equals the invoice ID var. That's what I'm wondering. I think we need to. Because, let's see, you're working on your cursor. Yeah. I'm going to copy this select into, and let me get it out here so you can see it. Before we declare our cursor, let's add in that code to create the invoice copy with our username, temporary table, and then our cursor, let's select from that table. It should pretty much be exactly the same. And we could get rid of the where clause, but we don't need to because those are the only rows we want. So now we're going to select from our copy, and we're going to update our copy. Let me leave that there for a second so you can see it. So instead of us all trying to update the invoice table all at once, we're going to select into our own copy of the invoices table. And then we'll use that. Getting all fancy. Now I'm going to continue on here. Sorry for veering off there. I was just worried about us all stomping each other. Brian's right, we're going to. Now, after we update the invoice, we're going to set a variable, our update count, up by 1. That's going to be the end of our if statement body. and the end of our while loop body. So now that we're done, we need to close our cursor, deallocate it so it's not taking up memory on our server. And we're going to have to see these cursor names should be specific to our session, but we might have to actually make these dependent upon our username if they're system-wide. Now, after we've deallocated, we're going to print out first nothing, then our update count, and have a nice informational message about how many rows were updated. Whenever you're ready, you can try and see if it runs, and we'll see if we're going to have any sort of conflict with us already.
I can't see anything.
Can't see anything.
It affected 11 rows. I changed names somewhere.
11 rows affected.
Okay, good. So it's letting you guys do it. We're not stepping on each other's toes.
Yeah, but I got some errors in
My query's being super slow.
And who's this cursor does not exist?
there. Did you change it to invoices to invoice? 'Cause that's, I had that issue.
I don't know. It's not very happy. Mine's not.
Uh-oh. Mine didn't like it the second time because it already existed.
Oh, okay. So we're stomping on each other. That's all right. That's what we wanted to see.
Fetch next from.
I'm going to see if we can look at our performance. So on the Amazon web server, I don't know if our server has performance information that's being maintained or not. Let's see if we can tell. So if you look, when we're running some of these queries, our server is seeing a spike in reads, read IO, and our CPU utilization is going up a little bit, but not too bad. So our little server here, our Amazon web server, we're running at what would basically be a free level for a person, a private person. We have to pay a small amount because we're not private people at the school, but not very much. So these are pretty usable servers for everybody, for you guys, because it's really being very performance friendly, because we're running some pretty intense queries with some of these, the way we're creating temporary tables. Now, we still are working with really small tables though. So that's a big difference compared to, you know, the real world type stuff. So we see that our cursor may be dependent upon the system level. Usually a cursor is going to be something that's written in a program that's going to handle things like that. We definitely would have to worry about it. And how could we handle those errors? Well, we could do try catch, just like in our other programming languages. So with our try catch for SQL Server, we're going to prefix those with the words begin and end. Begin try, begin catch. Yes, sir?
So is there a way to
delete a cursor by any chance?
When we closed it and deallocated it, that's deleting it.
Okay, because it had failed the first time.
Mm-hmm.
I went ahead and dropped the invoice copy table that I made, recreated it, and then it says the cursor already exists.
Oh, so somebody else is writing it. And so it might be something that we would have to, since there's canceled, it might not have cleaned it up. We might have to restart our server to get rid of that junk. We'll
I
see.
was about to say mine is currently still
Is it still running? Yeah, I think mine is too.
still running.
It's like still going. So we're just going to ignore that and talk about try-catch. So here's try-catch. If we have any sort of errors that we want to handle, we can do that. There is a facility called Surround with Snippets in SQL Server Manager. We were kidding a little earlier about being able to pop in that credit total minus blah, 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 minus blah, blah, blah. I don't know if we could with this snippet manager. We tried it a couple semesters ago and it wasn't really worth the trouble. Let's see if we can tell. The snippet is something that you insert in SQL Server Manager. So I'm just going to use this window that I have open. Mine is finally quit. And can I use tools? Let's look at Code Snippets Manager. In the Code Snippets Manager, I could say that I want to create a table, and I don't remember how. So I'm going to expand table and click Create Table and click OK. Oh, come on, you silly thing. Where'd you go? I could add more to it. How do we use them? Because this is like managing them. Like I could add more. Oh, nothing
there.
You have to read those words. Oh, no. It says chapter 11 tells you how to do it. Did you guys do it? I didn't. I don't remember. And I do remember it was not worth it. Oh, there it is. I right-clicked and on my control menu, insert snippet. Just what I was needing. Now, what kind of snippet do I want? Let's see. I'm going to move that up a little bit so I can see it better. I would like a table snippet. And yes, I want to create a table. And it pops that snippet of code in there for me. So Chris, we could actually create a new snippet for our credit total minus, or invoice total minus credit total minus whatever. And then we could snap that snippet into our code if we wanted to. So that's a Surround with Snippets that's available. This is our chapter of miscellaneous, oh, by the way, things.
Yeah.
Is it just still running? He's got that cursor all locked up.
Oh, I did good.
It's got the same numbers and mine's tying it out.
And then with our scripts, we've run through this whole time and haven't given you guys any lab time, but there's so much stuff for us to look at and talk about when we're talking about programming. These last few points are really important, and I hate it that we're getting to them right at the end. But these are system functions and system variables that are available to us. One of the most important ones that we'll be using in a chapter or two is the @ identity. If we insert data into a table that contains an identity column, where the number, the ID is automatically being generated by the database management system, how do we know what number got generated? So in our programs, if we're programming and we insert a new vendor, how do we know what vendor ID they got given? There are all sorts of ways we could try to figure it out. We could select that vendor using every other, a where clause that has every other field other than the ID. to try to make sure we got the exact right one. But what if we still had a duplicate? We still would be sure. They have a special system value variable available to us for that @, identity. So when I insert a row that has an identity column, the @ identity variable is going to be loaded up with the value that was given to that row. That makes sense. So I insert a new vendor, @ identity now contains the value of that new vendor ID that I just inserted. Now, along with that, when I complete a select statement, we always see that message of how many rows were returned. We can access that in the @ row count variable. So we're going to look at a script here. We don't have time to create it. We'll just look at it. Now, a couple of other system variables. @ error gives us an error number. Different database management systems will return different error numbers for things. The database management system that I used to work with years ago returns a 1205 if you're violating a duplicate's not allowed on a unique key. I've actually been in interviews where people have asked me that, 1205, and they're like, oh yeah, okay, you know. And that's kind of thing that they'll ask you. So you get used to the database management system, what kind of error codes it returns. We can actually query what the current table name is. Well, let me reverse that statement. We can return the most recently inserted table identity value for that table name. That's a mouthful. We can query to see what the server name is, our current host name, and what the current user is. So this script right here is very important. It's a really good example. It inserts a new vendor, and then it sets the identity column equal to @ identity. It grabs the row count. If a row was actually inserted, row count is 1, then it adds an invoice in for that vendor using the vendor ID that was returned. Stop it. And then it tells you, okay, we got it. We got a new row. Now, we also have some session variables that we can use. We can set our date format for our entire session, whether we want to have that row count value returned to us or not, how nulls are handled, how padding and pad characters are handled for variable character defined columns. And we could actually set a row count. So if we had a junior programmer that was just getting started, we could set their row count to, you know, a certain number so that they can't overload the system. We'll look at our dynamic SQL next time. Our last couple of chapters are like this, where it's just sort of some stuff thrown together that we've been wondering all along. And so we'll get through them. We don't have too much left. We're looking at chapter 14. We're looking at chapter 15. I'm in the wrong place. Here we go. Our scripts, then we're going to look at stored procedures, functions, and triggers. A stored procedure is basically a saved script. So we'll go from this chapter right into that one. It's almost the same thing. It's just that now instead of saying we run this script dynamically, we can actually save it and run it by command when we want to. And we'll see how we can make those kind of scripts run at predefined times or triggers that'll make our scripts take off and run.
So triggers just tell it when to run the script.
Mm-hmm. Pretty much.
Yeah, it's Tuesday, run Tuesday's batch.
Or run when somebody inserts a new row. Or
So are triggers built into, are those like you store them in the code that's called in? Or like,
they're stored in the database as objects like our views.
okay.
So then we can just access them by name like we do our views and those other things. This weekend, if you have a chance or find a chance to look up SQL injection. What is SQL injection? Because that's a really important thing when we're talking about why go to all the trouble to create these stored procedures, why don't we just do it dynamically? It has a lot to do with SQL injection and attacks against our system. So take a look at those. Have a great weekend.
We have calls like canceling this weekend.
Just Tuesday. Yeah, just Tuesday.
When I finally canceled that, running, it was 12 minutes, but it did say 11 rows effective.
So it did something, huh?
Well, it did something.
What you got, Robert?
Oh. Okay. Oops. Someone broke it.
Yours ran super fast. Mine must have been caught up.
I think it's because you and Riley did it at the same time. Yeah, and they clashed with each other. Collision somewhere.
Very well could have been. Yeah, because that's a zero update.
I know.
Interesting. Yeah, I kept using voice cursor, voices cursor.
Yeah.
I had to go on match. Oh.
Well, mine did it, but it's a 0 rows updated, so.
Yeah.
Just doesn't look quite right. You too.
Quick note about the C# exam that we just did.
Uh-huh.
I just updated my form to make it look a little nicer. It's the only change I made, just so you know. Just if you see
Oh
that,
my
then
gosh,
it
by
changes it
the
after
time we get to this point of the semester, I'm just like, if I can get it to work, I'm so happy.
It worked. But I wanted to play around with it because I didn't have the text boxes long enough, so I went back and rearranged it and played with them. And made
Oh,
them,
awesome.
just made it look a little nicer.
Is this the right one, Robert?
See you, Miss Riley.
See ya. Huh?
You got that?
I don't have an issue with two.
Which one are you having? This one. There it is. See ya. Yeah, yours is right, I think. It just looks weird.